Hello everyone, good morning. This is Muhammad Aga Nawalur Rahman. Today I am going to explain about the detailed information for wikis, which is like value of information in engineering information systems and knowledge management for IoT and blockchain in preventive maintenance. This slide shows you about our module, which is information technology and strategic management. Coming to the next slides, I will explain you about the value of information introduction and uses and examples of value of informations in engineering information systems. Yeah, yes. Here is the first wiki, which is value of information in engineering information systems. This slide shows you introduction and use of information in engineering information systems. Now, the main concept is we need to understand the main definition of the what is value of information. Let's go. The value of information is a concept used in decision making, like the main outcome of the company or results of the company, the main decision in economics and other information theory. It represents the benefits or worth of having additional information before making a decision. I can give you examples in next coming to the next slides. The difference between it is the difference between expected outcome with the information and the expected outcome without the information. It helps to decide how it helps to decide the results when we before making a decisions. I will give an example about the company. Imagine a company that's thinking about launching a new product. You are launching a new product. Launch the product. We have two options: launch the product in right way without any extra research, and gather more information first, like doing a market survey or customer survey and customer research to understand how well the product might do. Does information matters a company? If they launch without the information, they might spend a lot of money on a product that customer don't want. If they gather information first, they can make a smarter decision, maybe change the product or improve marketing or decide not to launch the product. It is basically how much the better company's decision become. Because of value of information, we can get exact decision when we make before the product launch. Now, I am going to explain value of information in engineering information systems. Here, what is engineering information systems? An engineering information system, which we can also called as EIS, Engineering Information System, is a type of information system designed specifically to support engineering activities. It manages processes and provides engineering related data and knowledge to help engineers to help engineers and organization collaborations. Here, these slides give the detailed information about the introduction, which is information is increasingly being recognized as strategic asset, particularly in the age of digital engineering. Engineering information system plays a key role in gathering data from design, operation, supply chain, and maintenance and transforming into actionable insights. I've told you this is the decision making for information engineering system, which is a which supports engineering activities to manage and processes the engineering related and knowledgement purposes. So the value of information in this context lies in how effectively it supports better Decision making improves operational efficiency, cuts costs, it rejects and reduces risks. The main important for this organization to understand the value before investing in information engineering information systems. The Here I can explain you the use of information in engineering information system strategic value. Engineering information system adds strategic value by helping us streamline design cycles, allocate resources wisely, and ensure compliances while minimizing errors. For example, for an instance, product life cycle management is a system allows the different team to collaborate effectively, reducing the product development by 20 to 50%. And this system empowers engineering and managers to make well-informed decisions, eliminate work and company, and rework and comply with the regulator standards. Here you can gain knowledge and about the use of information and how the cost reduce when you make the decisions about the company about the engineering information systems. Coming to the next slide, I will give the example like CAD. We can go for the next slide here. Yeah, here I can give the clear examples for CAD, which is also known as computer aided design data integration. In this slide, there is an example risk mitigation and value type like tangential and intangential. A clear example of value of information in action is CAD, uh, which we also known as computer aided design data integration. When CAD files are connected to a centralized engineering database, issues like version conflicts and redundant work are eliminated. According to Rajaba Linjand and Spitas, who are the professors of aerospace engineering and head of the department in mechanical, material and manufacturing engineering, and they studied at the University of Nottingham in China. They research about spans advanced engineering design, including multifunctional composite shell structures, which is comes under mechanical, thermal, and electrical integration conditions, and high-speed torque, high-efficiency powertrains. They research on this program, on these structures, composite shells. They research they research on integrating CAD data through engineering information system reduces design errors by 35% and improved delivery speed in the aerospace industry. Rajaba, Linjed and Spitas are the professors for advanced engineering, aerospace engineering. And coming to the risk mitigation and cost evidence, another critical aspect of value of information is its role in risk mitigation and cost avoidance. High quality, timely data reduce the uncertainty around potential equipment failure. Predictive maintenance system are an examples for risk mitigation and cost evidence. They use historical data to anticipate failures and prevent unexpected downtime. This is essential in industries where downtime can cost hundreds of thousands per hour. There are two types of tangible and intangible. The value of information is both tangible and intangible. Tangible, which means the benefits in intangible, there are benefits include cost saving, shorter time, and less time in the market, and increased production yield. On the other hand, intangible benefits such as improved team collaboration, enhanced morale, and reduced export to risk can significantly impact long-term performance even if they are not directly measurable. A balanced perspective on both types of value helps just investment in information engineering systems. These are the benefits of tangible and intangible, and examples of CAD, computer aided design, and these data. This slide shows about this. And coming to the next slide, coming to these slides here, yeah, here this slide shows the some information about balancing tangible and intangible information value. As of now, I would say that there is a cost savings and better collaboration in intangible, and cost saving in tangible, and reduced time. These there is a balancing in tangible and intangible for value of information. And however, simply having data is not enough. The quality of that information is crucial. For data to be useful, it must be accurate, timely, complete, and relevant. Poor quality data leads to poor decisions, which in turn increase operational challenges. Research has shown that the contextual value of information is often more important than its quality. How to ensure how quality information for decision making is the main concept here. Using information quality to make decision, the main is we need to take high quality data which is useful. Research has been doing for the context value of information, and here measurement of the value of information. To measure the value of information in engineering, we look at the expected improvements, the main improvement that are results from better decision making. Two methods often used are the expected value of perfect information, which we also known as EVPI, which is expected value of perfect information, which assumes ideal data, and expected value of sample information, which is also known as EVSI. There are two methods, EVPI and EVSI. The first method is expected value of perfect information, which assumes ideal data, and the expected value of sample information, which estimates the value partial information under uncertainty. And these approaches helps quality how much better outcome can be used due to improved data. How to ensure high quality data information for decision making is there are two methods, which is EVPI and EVSI, expected value of perfect information and expected value of sample information, which we can get high quality information data for decision making. As of you know that the figure shows you about how to ensure high quality data information for decision making. Coming to the next slide, I will give the practical example for value of information in engineering information systems. Yeah, in this slide you can observe how to quantify the value of information. Let's see. uh, EVPI, there I already said you EVPI and EVSI. EVPI is provides the maximum potential value by assuming perfect information, and EVSI, which is estimates value based on sample information considering uncertainty. The when you see the case example, investment in the predictive maintenance system, the main scenario, like a company that oil refinery is considering investigating a predictive maintenance in engineering information system, which will be lower the time at a standard of equipment. Like you can a practical example can be seen in a oil refinery considering investment in predictive maintenance system. The current downtime cost is 180,000 pounds per hour, and the refinery losses around 60 hours annually. by implementing an engineering information system with a predictive 40% reduction in downtime. The company could have save like 4.32 millions annually uh, in ponds. Subtracting the 1.5 pond 1 million ponds implementation cost, the net benefit in the first year is, that is the net benefit, that is 2.82 million ponds. This clearly shows the slide return on investment that comes from informed timely decision making enabled by engineering information systems. The net benefit is over, for the first year 2.82 million. This is clearly shown in the slide. Okay, this is the practical example for investment in the predictive maintenance systems for information engineering systems. I have already give the calculations about the uh, results also, savings and net benefits, and also, and everything is covered in the slides. Uh, Coming to the next slide, there is a conclusion. Uh, in the conclusion, the value of information in engineering system is closely tied to reducing uncertainty, improving operational performance, and guiding strategic decisions. By using high quality data, companies can gain economic and performance uh, in advantages. Investing in engineering information more than just examining technical capability. It is clear that it demands a clear understanding of how improved information drives better results. The main concept of the value of information in engineering information system is to get a better decision for a company and perform highly advantageous and demands a clear understanding of how improved information drives better results. And there is also shown as sources. If you have any doubts, you can go through these sources. uh, Kleiman Orti and Rajaba Langen and Stark. There are other sources also. You can go through that for you have any you if you need any information, more information about the value of information in engineering information systems. Okay, I will explain you next wiki, which is knowledge management for IoT and blockchains in preventive maintenance.